These are the notes for 3.4 lines in motion. And this section is kind of sandwiched in between talking about functions in general to moving on to talking about graphs of functions. And the reason we have lines come back into play, and lines can definitely be a function, is to talk about how we transform functions. And today we're going to talk about just a translation. Translation is a smaller category of the bigger category of transformations, but how we move graphs left, right, up, and down. It's useful to talk about it with lines first because we can talk about it as point slope, something you guys are familiar with. When we did point slope in previous chapters, we did not discuss it as a transformation. It was more or less how we did equation writing. And given a point, given a slope, that kind of thing. So we're going to approach it a little bit differently, use the idea of point slope, and then kind of modify it to fit our function style of thinking. And then if you have that down, the basic translation idea, as we move on in the chapter, then we can relate it to our other functions, ones we haven't studied. So that's the basic idea. Let's get going with how point slope relates to the different way of us thinking about it, which is translation, and using a little different format. A quick reminder of the forms of the equations from previous chapters. Y equals mx plus b, the equation of a line slope-intercept form. And then y minus y1 equals m times x minus x1, our point slope form. We're probably going to operate a little bit more off of this today as a way to relate to what is the new way of us sort of thinking about it. And again, that'll lead us into how we deal with other functions. We want to translate them or move them around on an xy axis. First of all, a couple of questions we're going to try to answer are slope, y-intercept for the first one. For blue, for red, slope and point, green, slope and point, and then we're going to do it again relating like what has happened as you go from the blue to the red to the green. And then of course we'll take a look at the graphs. So going down the list here, you'll notice that all of them have the same slope, so we can tick that off real quick. Slopes are all 2. If this is the mx plus b format for the first one, then the b not being there means you've got a y-intercept of 0. Points, we've done this the other direction in previous chapters where we give you a slope and a point and ask you to plug them in. Here we're taking them out, so when you take it out from equation to coordinate, we have a sign change, so y minus 2, 2x plus 3, negative 3. We'll talk about that actually in a little bit too and how that relates to translation. Same thing here coming out of our equation, our coordinate's going to be 1, negative 4. Now doing some comparison, let's start with our blue graph. Excuse me, there we go, I pop it up. So a y-intercept is 0 and a slope of 2, so we're running a slope up 2 over 1. You notice these are all special kinds of lines in terms of how they're related by slope. Think about it for a second, you guys can answer that question. They're parallel. And then the idea is, where are the other ones at? Well, if we were operating off of graphing these without having a y-intercept that we know from the equation just by a quick look, and not having to like rewrite it into mx plus b, we could just go from the coordinate. We could start at negative 3, 2, and from that spot, we could actually run our slope. So yeah, we like a y-intercept if we've got one ready to go, but if we don't, turns out you can use the point, plot your point, negative 3, 2, run your slope up 2 over 1, up 2 over 1, up 2 over 1. So that same attack or approach, I can plot my coordinate 1, negative 4. So 1, negative 4, and draw that line, and from that point I can run my slope, positive 2, up 1 over 1. The question we want to get to is start to work our way into is what is the translation idea? So we can then kind of get us into a function sort of format way of thinking about it. Or just move to other functions really in general. And the thing we want to do is say if we're going from this one, which we say really has no, the reason we can say it has no shift is because its y-intercept is 0. So we're basically starting at the origin. That's the way we'll think of all of our other graphs as something, one particular spot, and that'll be unique when we get into our other graphs, called a vertex. But for now, one particular spot where we start, and then how do we get to these other graphs? And we get to them by moving left, right, up, down. So if you think about it as a simple counting idea, how did we get there? Well, we went left and up. And how did we get here? We went right and down. Now, when you write these equations in these forms, especially in the past, we never thought about it as a movement. It was more or less plot a y-intercept, run a slope. Or even talk about just plot a point, run a slope. We're actually talking today about the movements. So it's starting to describe things as left, right, up, down. From a 0, 0 location, from a 0, 0 start. Okay, so in terms of just describing that, how did we get there? Clearly, we're talking about this one again, left and up. How did we get there to green, right and down? So now we're going to try to take that same concept and kind of change the way we talk about it a little bit, change the way we symbolize it a little bit. We won't change the way we talk about it, but how we symbolize it. And bring in some new notation. So this is kind of going to sort of take us back to that function notation a little bit. It sort of has that, still has that point slope look to it, but we're going to transform that again in just a minute. So y minus k, f, x minus h. Now if you look at y equals f of x as the way we look at it, think about our equations, then insert your left, right, up, down. The movements do what you expect. I think these are kind of the obvious ones, positive up, negative down. These I think kind of mess with your head a little bit, but I'll explain how we can get over that real quick. Y is negative or minus h to the right when you think of negative as moving to the left on an x-axis. And y is positive to the left when you think of positive as actually being to the right on an x-axis. And a real simple way to translate that idea. So now what we're going to do is look at equations in a certain format. We're going to change the format a tiny bit on you guys, but still say what is the, how do we get there? What are the movements? So a couple things. We're going to kind of switch our way of thinking a little bit, have this sort of f notation. And then finally we're going to write it as not so much point slope, but just have it read as a y equals equation. So in other words, get that k moved to the other side. Now as you guys look at the equation, I think you think of the positive 2 as definitely up, but how is the plus 3 to the left? And the way we deal with that is, again, pretty simple. And so I'll show you how to wrap your head around that real quick. Take that x plus 3 and set it equal to 0 and solve for x. And what you get then is x equals negative 3. And now your brain can connect. Negative is a left movement on an x-axis. The reason it is that way, the reason it appears that way is because it's in a set of parentheses, right? So basically if you thought about it, well, this tells me to go left 3 and I worked my way backwards to an expression. This also tells me to go left 3. So you kind of got to get used to it. I suppose if you think of it as opposite, that might help. Kind of like when you go from equation to coordinate on the previous page, how that happens. Now, on the other hand, because we're going to move the k number over, there is no opposite thing going on. Plus 2 is actually up. So that's up for sure. So in here, we're going to have to pay attention to this idea. Here, the number does what it says it does. With a similar kind of perspective, saying right and down, you know, when you move this number to the other side, I think negative... Sorry for the interruption there, but again, I would say I think negative 4 in this instance definitely to me means down. Negative is down. And by the way, that one there should be 1. Let me just fix that quick to match. But when I go to do this, you know, how do I reason out as being right? And what I do is I think about, again, what if I just set that equal to 0? And you don't need to set it equal to 0 on paper. This is just kind of today, you know, getting that idea straight in your head. I think after doing enough of this, you'll just kind of get down, okay, you know, going from parentheses to a direction, it's just like going from equation to a coordinate is still an opposite idea. But if you solve that equation, you're going to get x equals 1. And so x being a positive 1 is definitely a right movement of 1. So that's where that comes from. And again, you got to kind of sort of undo it in your head a little bit to get yourself to the correct way of moving. But again, you'll get used to that pretty quick, and all of a sudden, no big deal. So when I see that, even though it says minus, I kind of got to think about this for a sec and go, all right, that's actually right. Now, what I want you guys to be able to do then is look at an equation and just describe it. Like, what are the movements? So x minus 5 plus 8. Right 5 up 8. So again, up is positive for sure. You look at this and just for a second, your brain might kind of go, wait a minute. But remember what we're doing then is x minus 5, if I set equal to 0 in my head and solve, I would definitely get a positive 5. Or you can say from parentheses to the movement, to thinking about the movement, that it's, you know, opposite, just like going from equation to coordinate. But I think at least today it's not bad to think about this as how I understand what's happening with those movements. Okay. Last thing to do is just kind of do a little more practice with the h and k concept. So I didn't really say much about h and k in the first couple slides, but your h is left and right, your k is up and down. And what we're doing here is saying here is a parent function, or a function that has no translation, no left, right, up, down, because you know you got a 0 y-intercept, and insert these changes into the equation, write a new equation. First thing to do is ask yourself, what are h and k? Now in this case it says left, so I'm going to write down h as left as negative 7, and down as negative 5. The only catch is when I go to put it in, and I put in that negative 7, what's going to happen here is minus and minus, it becomes a plus. And so now my new equation reads the way it should, and I have that opposite idea going on with my h. So here we go. y is equal to. Now, when you go to put it in, make sure you put into the new function. So 3/4. Then I do a parenthesis, and then x minus a minus is a plus, and then my k minus 5. Again, I think pretty easy to do if you just follow this format, especially if you guys probably won't do this a whole lot the second or third time you do it, but the first time you do it, maybe just write these numbers down so they actually go in just as you would expect, and then all of a sudden that plus is taken care of. Same thing here, as it reads. Now, we might use the words horizontal and vertical on you guys. So just to be clear, if it says -2 horizontal, then we're talking about that being a left movement, and 4 units vertically is up 4. So because it doesn't say -4 units. So again, we just think about that, how that translates. Operate off of this. Insert your H. Insert your K. Now here we're not even giving you like a specific function, right? Just a real generic way of talking about it. So we're going to use the generic way of writing it. We're just going to use this as our model and just work right off of that. So if I do that, again, what I can do is go minus a minus is plus. So I got my +2. Oops, try a plus here. And my k is 4, and I put in my 4. So now, again, generic function, generic way of writing it. All this really says is whatever function we have, what's the movement? It's left and it's up. All right, last thing to do before I wrap this video up is visually do the same thing. So can you visually describe the transformation? Again, I got a function described as just some graph. It's not a line. It's not a graph. It's not a family of functions that we'll necessarily study, but just a graph made up of multiple lines, which has a name called piecewise. But again, what are the changes? Now, as you look at the changes, it's as simple as going, well, how do I get from there to there? What's that movement? And any of those points will work. You don't need to, of course, need to use all 4. But if I'm just counting from common point on the graph to the other point, it looks like I'm going right 2, down 3 to get myself there. So then I'd want to say right 2, down 3. When I go to do the generic version of this, again, I'm just going to insert right 2, down 3. Oops, try that again, down 3. When I go to put that 2 in there, because it's not negative, right, it literally translates just as we'd see it there. Okay, so a couple things, right? We're trying to use the point slope idea early on, make that connection to how we can move, and then sort of fade away from point slope and get into this H and K sort of style of talking about it, which is, as we go to other functions for the rest of the chapter, we're definitely going to stick with this. And we don't really have a point slope thing going on anyway as we move to other functions, so it makes a lot more sense to use this. So once again, it's kind of getting used to notation, but trying to relate it a little bit to things from the past. And that'll do it.